Hello viewers, I am Kausalya. Today we are going to solve problem number 6 under the topic Nyquist plot. So before solving the problem, it is better to know the procedure. So I am giving the link in the description. Kindly go through it. Then it will be very easy for you to solve the problem. Now the problem is construct Nyquist plot for a system whose open loop transfer function is given by this. Find the range of k for stability. So here the transfer function is given. From this transfer function we have to tell for what values of k the system is stable. The first step is finding the number of poles lying on the right half of S plane. So here this is our problem, right? And the denominator term represents poles and the numerator term represents zeros. So in denominator I am having S cube. So when I equate this to 0, here the value of S is 0. Again here they are known as zeros. So again I am equating this term to 0. So 1 plus S into 1 plus S because I am having 1 plus S the whole square. So once I solve, here the value of S is minus 1 and minus 1, right? These are poles and these are zeros. So the first step is number of poles lying on the right half of S plane. So when you draw the S plane, again this is our S plane here. The poles are lying at origin and they are 3 in number, right? Because the power is 3. So here I am having 3 poles at origin, right? And the next thing is I am having 2 zeros which are lying at minus 1. So here I have marked that, okay? Here we are having 2 zeros. So is there any pole lying on the right half of S plane? No, nothing lies on the right half of S plane. So here it is 0. And in step 2, number of encirclements, this is given by n is equal to p minus z. P is nothing but poles lying on the right half of S plane and z is nothing but zeros lying on the right half of S plane. So just now we have seen, right, all poles and zeros are lying only on the left half of S plane, right? So here both the values are 0. So the number of encirclement is 0. And step 3 is drawing a rough Nyquist plot. When you look at the problem, you see here we are having poles at origin. So the rough Nyquist plot should not cover the origin. That's the concept here. Right. So here you see this is not covering the origin here. So this Nyquist plot totally consists of 4 sections. You see, first it starts from plus infinity and ends at plus 0, and section 2 plus 0 to minus 0, and section 3 minus 0 to minus infinity, and section 4 is minus infinity to plus infinity, right? Step 4 is finding expression for magnitude and phase angle. So this is a given problem. Here we are replacing S by j omega. So the first step is we are going to find the expression for magnitude. So the magnitude expression is given by g of j omega h of j omega, right? So here it is given by k into, here this is the value, so I have to take square root as well as I have to square the terms. So square root of 1 plus omega whole square to the power square, and again we have to take a square root. So this square and square root cancels each other, and similarly here you see omega cube whole square, and again I have to take square root, and these two terms cancel each other. And finally, the expression is k into 1 plus omega the whole square divided by omega cube, right? Now we are going to find expression for the phase angle. So this is given by, again, look back here. So how to write the expression here? Tan inverse of imaginary coefficient divided by real term. So here the imaginary coefficient is omega and the real term is 1, right? So tan inverse of omega by 1. Since we are having a square, right, here we have to write it as 2 into tan inverse of omega by 1, right? And again you see denominator I am having a omega cube. A single omega produces an angle of 90 degree. Then what about omega cube? 90 plus 90 plus 90 gives rise to 270. Since this is the denominator term, I am going to shift this to the numerator. So here I am having a minus sign. Right. Now we are going to analyze the section. So first section. So first section where it starts at plus infinity and it ends at plus 0. So just write down the values. It starts at plus infinity and it ends at plus 0. So now just substitute the values here. So this is the expression for the magnitude. So omega is infinity. So anything divided by infinity is 0. And again when you substitute infinity here, what happens? Tan inverse of infinity is nothing but 90 degree. And again 2 into 90 degree gives 180 degree. Right? So 180 degree minus 270 degree. This gives rise to minus 90 degree. Right? So here I had written that one. And the next case, substitute 0. When omega is 0, anything divided by 0 is infinity. And again, when you substitute here, this entire term becomes 0. So the angle is minus 270 degrees. Right. And how to find the angle of rotation? We have to subtract like this. That is minus 270 degree minus of minus 90 degree. So this gives rise to minus 180 degree. So this negative sign indicates we have to rotate in clockwise direction. Right. Then we are going to analyze section 2. So again, so in section 2, it starts at plus 0 and it ends at minus 0. Right. So here plus 0, it ends at minus 0. Again look back at the expression here. So anything divided by 0 is nothing but infinity. Right. So here I had written infinity. Again substitute the value of omega as 0. When you substitute omega as 0, this entire term reduces to 0 and finally we will be having minus 270 degrees. So just write down the value as minus 270. Right. And the next thing is substitute the value of omega as minus 0. So again anything here, anything divided by 0 plus 0 or minus 0 is infinity. So here I am writing it as infinity. Only here in the expression for phase angle, when you substitute minus 0, what happens? We have to introduce another minus sign. That is minus of minus 270. So that gives rise to plus 270 here. So when you solve this, what happens? The angle is plus 540 degree. Plus indicates we have to rotate in anti-clockwise direction. And regarding section 3, it is nothing but mirror image of section 1. Right? It is very clear from the rough Nyquist plot. And finally section 4, it is not needed. Now we are moving to our step 5. It is nothing but rationalizing. So this is our given problem. We have replaced s by j omega. So rationalizing is nothing but we are just going to change the sign of the denominator and we are going to multiply and divide by the same term. Right. So here you see I am having plus j omega whole cube. So here I had taken minus j omega whole cube divided by again minus j omega whole cube. Right. And here this is of the formula a plus b whole square. Right. So this is a and this is our b. So what is the formula? A square. So 1 plus b square. Here b is j omega. When you take j omega whole square, that gives you minus omega square. So here I had written plus 2ab. So plus 2 into 1 into j omega. So here I had written as j2 omega. Right. And again j cube. J cube is nothing but minus j and omega cube is omega cube. Right. Then the next thing is we are going to multiply the terms. So here as usual 1 into j omega cube. Similarly minus omega square into j omega cube minus j omega 5. And again plus j 2 omega into j omega cube gives to minus 2 omega to the power 4. Right. And when you multiply these two terms, omega cube into omega cube, omega to the power 6. And j into j minus 1 gets multiplied with this minus again. So this gives a plus sign. So here comes plus omega to the power 6. Right. Now we are going to separate the real and imaginary terms. So when I separate the real and imaginary terms, our expression is like this. Right. And now here omega to the power 4 and here omega to the power 6. So these two get cancelled and finally here I will be having minus 2k by omega square. Right. In this case here I am taking j omega cube commonly outside. So the remaining term will be 1 minus omega square and this denominator term comes here as such. And these two terms cancel each other and finally I am having an expression like this. Right. Now we have to proceed as usual. First step is we have to equate imaginary term to 0. So here when you equate this imaginary term to 0, you see what happens. This is our term, right? So 1 minus omega square. When I move this k by omega cube to this side, what happens? It will be omega cube by k. So anything multiplied by 0 is again 0. So again when I move this minus omega square to the right hand side, that becomes plus omega square. So what is the value of omega? It is 1 radian per second. Right. Now substitute this value in real terms. So here what is our real term? Our real term is this one, minus 2k by omega square. So just substitute the value in the place of omega, substitute as 1, and the value of q is minus 2k. Q is nothing but intersection of the negative real axis. Right. Now we are going to draw the original Nyquist plot. Right. So this is our section 1. This is starting point, ending point, and this is the angle of rotation, right? So it starts at 0 minus 90 degree, right? So this is our minus 90 degree line and it starts at 0, right? And it covers minus 180 degree. That is, it covers 2 quadrant in clockwise direction, right? So it starts here, it moves in clockwise direction, and where it gets ended, it gets ended at infinity minus 270 degree. So this is my minus 270 degree line, and it starts here at origin at minus 90 degree, right? This is minus 90 degree line. So it starts here, it moves in clockwise direction, and it gets ended here, right? Next, section 2. So it starts at infinity minus 270. So this is my minus 270 degree line and this is somewhere infinity, right? And it has to be rotated 540 degrees in anti-clockwise direction, right? That the plus sign indicates anti-clockwise. So here you see, I'm starting here, right? 540 degrees. So you see 90 clockwise, right? Sorry, you have to rotate anti-clockwise. So I am moving like this. So 90, sorry, this line, 90, 180, right? I'm starting here, right? Infinity minus 270. So I am starting here. I have to rotate in anti-clockwise direction. I have to rotate 540 degrees. So I am starting here, you see, 90, 180, 270, 360, right? And again, I need 540 degrees. So again, I need to rotate 180 degrees. So here, again that 90 and 180. So totally 540 degrees I have rotated in anti-clockwise direction. You see the arrowheads, right? It moves here and again it moves and it comes over here. So I had rotated 540 degrees, right? Hope you people understand this. And the next thing is, again, section 3 is nothing but it is the mirror image of section 1, right? So this is our section 1. So how to draw the mirror image? So I had drawn mirror image in dotted lines. You see, this is the section 3. Right, and section 4 is not needed. So again here the value of r should be, r is infinity. So this is our final Nyquist plot. Hope you understand, right? Yes. Now we are going to find the range of k for which the system is stable. So here, what is the value of q? Just now we had find it as minus 2k, right? Now we have to find the range of k for which the system is stable. And what is q? The intersection point on the negative real axis is q. Now we have to find out the value of q so that we can tell whether the system is stable or unstable. Now you see q is equal to minus 2k, right? And what is the value of this minus 2k? That is, here the maximum value should be, that is minus 1 should always lie outside, right? So the value of q should be, it should be less than minus 1, right? Both means the same here. So that is the reason here I am equating the value of 2k should be less than minus 1. So when you solve, what happens? The value of k, that is these two minus sign cancels each other and the value of k should be less than 1 by 2. So the system will remain stable when the value of k lies between 0 to 1 by 2. Right. Here comes the end of the problem. Hope you people understand well. If you have any doubt, let me know in the comment section. Thank you.